Alright, let's start with our first experiment. We're gonna make some blood. First, start with an empty bowl. Add 1.5 cups of this gooey, goopy, sticky glue. I'm gonna go a little more. I need all of this glue. Oh. Now, here we have a bit of warm water, about 2¼ cups. We squeeze in a tablespoon of this red food color. Pretty. Now we stir a little bit. Ooh, now, because blood isn't bright red, unless it's in the body and I'm drinking it, we're gonna add a smidge of this brown. I would say smidge, and now we stir. Oh yeah, this color is becoming perfection. I would know. Now, here comes the starch in liquid form. About 1.5 cups if you're following along at home. Now here's the deal. You gotta mix it fast before it coagulates like real blood. Oh, this is gnarly. Oh, goodness. Yes, it's perfect. Gotta say, I've seen a lot more blood than most actors out there. And I gotta tell you, I haven't quite seen any like this, except in a slime movie. This looks like something horribly went wrong. We've got vampire guts. I'm not exactly sure what makes them vampire-y, but we're gonna give it a try anyway. I've got 2 bottles. This is atomic slime fluid. Official name, atomic slime fluid. I'm gonna pour this into this bowl. Now, we're gonna add activator solution. Ooh, fancy name to the atomic slime fluid. Now, with a spoon, or with a whisk, I'm gonna mix 2 solutions. I'm going to stir this for a little while because the atomic slime molecules aren't going to just mix themselves. Alright, here we go. Uh-oh, alright. I still don't really get why they're called vampire guts, unless vampires are eating honeybees. Oh! So now, guys, these vampires who shine a black light to see what they've been eating, that is a... Oh, that's a cat. Yep, this vampire ate a cat. I'm a scientist, but I've never done this one experiment. Elephant toothpaste. We start with these. Now, we have some hydrogen peroxide, right? Ooh. Here comes some food coloring. Blue, it's the color of the sea and my eyes. Green, because it's the color of trees and money. And we're gonna go yellow, because it's the color of the sun. And this is soap. This is a mixture of yeast and water. We call it a catalyst. I call it really stinky shit. Now, we pour it in, and we stand back. Whoa! Yes! We finally made something work!
These are army ants, and they are making a living bridge of their own kind in order to invade and conquer a hornet's nest. What might be the most terrifying is that these creatures can actually kill and eat 100,000 animals a day. It has even been rumored that they can kill and eat things like cows and even people.
Funciona!
Welcome to Cap or Slap, where I test TikTok trends that I think are cap, but once I'm proven wrong, I have to get slapped. Let's see if this actually works. Here we go. What the heck? It actually worked. Whoa.
The people who haven't seen it, this is the video where a bullet is shattered when it hits a glass Prince Rupert's drop. It is a 38 special, and you can find this video on YouTube. That's the name of it.
How many holes does a straw have? People have weirdly strong opinions about this question, but there is a mathematically correct answer from the field of topology. 27! No, but I like the way you think. The 3 most common answers are A, 2 holes, 1 at each end. B, 1 hole, it's just a hole all the way down. Or C, no holes because it's a cylinder and that's a continuous surface. Unless it's a leaky straw. Those are the worst, am I right? So what's the answer? This blob has no holes. Now it clearly has 1 hole. Now I extend that hole out into a cylinder without ever poking another hole. Still leaving 1 hole. See, it's a straw. I should never go into pottery. Mathematically, a straw is a circle with 1 hole times an interval with no holes, leaving still a shape with 1 hole. Math is fun.
But I don't need drugs, 'cause I'm already high enough. You got me good. I'm already high enough. I only got eyes for you.
The new COVID variant is called Omicron, and this is what you need to know about it. I'm a scientist who studies COVID-19, and today is Monday, November 29th. Omicron, also known as B11529, is a newly designated variant of concern. Omicron seems to have picked up dozens of mutations. However, right now it's really hard to predict exactly what that combination of mutations will do. I want to emphasize that simply having a large number of mutations does not necessarily make the virus much worse. There are a few big questions that researchers are currently working to answer. First, does the Omicron variant evade infection or vaccine-mediated immunity? If so, by how much? To test this, they will take blood samples from people who were vaccinated or infected and incubate them with the new variant in the lab to see how well the blood samples can inhibit the virus's ability to infect cells. This is called a neutralization assay. It takes a couple of weeks to isolate the virus, grow up the isolated virus samples, and do the experiment. Second, how well do the COVID vaccines protect against hospitalization due to Omicron in real life? This will take closer to the order of months to answer, which is why it's good we're going to have neutralization data pretty quickly. Before I forget, please do make sure to like this video so that more people can see it. Third, is the Omicron variant more infectious than Delta? We've seen some variants in the past that have appeared to be somewhat more immune resistant in lab studies, but none of those were really able to outcompete Delta infections in the actual population. Beta variant is a good example of this. Until we see some more real-world evidence on whether Omicron can outpace Delta infections, it's going to be hard to tell whether it's more or less transmissible. Fourth, is the Omicron variant more virulent, meaning does it cause more severe disease? This is also very tricky to answer due to the many confounding variables that influence COVID outcomes, but it's going to take also closer to months. A final point is that it is exceptionally unlikely that this variant, or any variant that might arise in the future, will be totally resistant to prior immunity from infection or from vaccination. That means that being vaccinated will still reduce your risk of severe disease outcomes. And what researchers are really trying to answer right now is, if it is reduced at all, by how much is it reduced? It's not going to go to zero. So until we learn more about Omicron in the coming weeks, right now would be an excellent time to get a vaccine. If you were vaccinated more than 6 months ago, get a booster. If you were infected in the past, you should also get at least 1 dose of a vaccine because it's going to take your infection-mediated immunity and it's going to give it at least like a 5-fold, maybe a 10-fold boost in strength in neutralizing antibodies. Right now, we honestly don't know enough to tell whether Omicron is a big concern or not really a big concern. And the measures being taken right now are preventative. In case we end up finding out in a few weeks, it really is a big concern. Make sure to give me a follow if you want to stay updated. I'll make an update when we actually have more information about Omicron.
Top 3 events that are yet to be observed to occur naturally. Alright, number 1, we got you pulling up to the function with some hose.